this is our 19th lab of the year. It's our first lab of semester 2. We are doing rotational motion. This is my meter stick, and I have my fulcrum or my pivot point set up here. The purpose of our lab today is going to find the mass of our meter stick using torque. So we're going to put some random masses on here and level this thing out, and then use that to calculate the mass of our meter stick. So the first thing we need to do is find our center of mass for our meter stick, which I already did. So these fulcrums are kind of finicky. So this is pretty close to even as we're gonna get. So you move it a little bit and it tips. So by doing this first, we find where our center of mass is. So when I draw my diagram, I'm going to draw my gravitational force for my meter stick at this point that we figured out the mass is half on this side and half on this side, which is why it's balanced now. So we're going to have to change where we have our fulcrum for our meter stick, because right now our meter stick is not providing any torque in one way or the other way, or the rightward torque is canceling out the leftward torque, or clockwise and counterclockwise. So we won't be able to use this information to help us calculate our mass. So we need to set it up like this so we can find our center of mass, but then we're going to change this location to help us find our mass. So first things first, we're going to record what this center of mass is. Normally it's around 50 centimeters, but for this one I measured it to be 50.3 centimeters. So 0.503 meters. And this is important when I go back to do my calculation. So now I'm just going to move my fulcrum. It doesn't matter where you move it to as long as it's not out of the center of your mass. So you'll see that this will rotate in this direction because there's more mass on this side. So this side of my meter stick is providing more torque than this side of my meter stick. So I have some masses. I'm going to add them to my meter stick and see if I can't get it to be balanced horizontally again, or close to horizontal. So this part you can do with any combination of masses at any distance from your pivot point. Okay. I have my assistant. All right, let's see. All right, that's going to be too heavy. Still too heavy. You know what, I'm going to just. Okay. Pretty close, pretty close. Hopefully when this stops rotating, it'll be horizontal. So the way I'm going to set up my equation is my center of mass is on this side of my fulcrum. So I'm going to use from the fulcrum to my center of mass is my lever arm distance for the meter stick. Right, the gravitational force is going to be from the center of my meter stick. So the lever arm distance for my meter stick is going to be from the fulcrum to where the center of my mass is. So I did change where this is, so we need to record where our fulcrum is on our meter stick so we can take the difference between the center, look at that, is like perfectly even, the center of our mass to our fulcrum. So our meter stick is going to be going this way. The way I'm looking at it, it's going counterclockwise. And these two masses, they're both different lever arm distances away from our pivot point. So we've got two different torques that are heading, is the way I'm looking at it, clockwise. So the lever arm distance and the gravitational force of this mass plus the lever arm distance and the gravitational force of this mass will be equal to the lever arm distance from my fulcrum to the center of mass of my meter stick times the gravitational force of my meter stick. So we have G, but we don't know what the mass of our meter stick is. When we write our equation out, this will be the only unknown variable. So let's take some recordings, or we could probably get it up. So this mass is 50 grams, and this mass is 100 grams. I'm going to come to the other side. So my fulcrum is set at 39.7 centimeters, and this 50 gram mass is at 16.3 centimeters away from here, so we have to take the difference to get this lever arm. And then my 100 gram mass is at like 10.7.